Okay, ready to go live. Okay, thank you everyone for joining us today for our Falchi Solar and GoodWe webinar. Thank you once again to all the people who joined us yesterday for the presentation on our complete portfolio and our commercial industrial solutions for three-phase units. Today's presentation with GoodWe and Falchi are going to basically concentrate on our energy storage solutions. I'm just going to quickly hand over to Patrick at Falchi so he can just give a brief introduction for those of you who weren't with us yesterday. Thank you, Patrick.
Thank you, Raj, and welcome to our second webinar. My name is Patrick, and together with Abhilash, we founded Falchi Solar, the first wholesale distributor of solar products in the southern and western part of Ireland. I'd like to give you a very brief overview of Falchi Solar. We are located in Shannon, in the Western Business Park, at which we have a very large building, 20,000 square foot, of offices, showroom, training facilities, and warehouse. We'd love to invite all of you to come and visit us and to see firsthand the stock we have and the showroom that we are very proud of. Our warehouse is full at the present time of solar panels, batteries, mounting gear, and of course, inverters. And we're delighted that GoodWe is our partner as far as web inverters are concerned. What do we offer? What does Falchi Solar offer? We offer a complete service to the solar industry in Ireland. One-stop shopping, overnight delivery, good technical support, and after-sales services. We have very shortly a Falchi app, which will be very, very helpful in looking up everything we have and how to order. Let me also tell you that in conjunction with this seminar, or webinar, Falchi Solar is offering a 5% discount on any orders received. Our website is www.falchisolar.com, and our phone number is 061 475-5839. We invite you to register with us, and you will have complete update information on all the products we have. Now, I'd like very briefly to introduce to you some of the GoodWe products that we have in our showroom, and I'm going to ask Craig to show them to you.
Okay, brilliant. Falchi have actually got, just straight ahead of us, a dual tracker inverter, a DNS unit for 2 MPP trackers, a residential inverter. Yesterday, just to the right of that, we spoke about the XS series. Now, these are fantastic for projects, social housing, council house projects for local authorities. They're small, very lightweight, compact. As I said yesterday, the fascia there is the size of an A4 sheet of paper. One tracker, one DC input, and very easy to install, and very well priced. Just to the right of that, we have, Craig, if you just want to drop it down a bit, is a 3-phase unit. Now, this is a commercial unit, part of our SMT range, and it just goes to show how small, lightweight, compact they are, and the technology within them actually do the job of a bigger inverter, which is a big cost-saving benefit. Okay, right. As today's, we're going to be featuring energy storage. Just directly in front of you there, I can see that's an EM single-phase residential DC hybrid and there's some Soluna batteries just underneath which Bauchi sell. So basically, it just goes to, again, the size and the compactness of the technology that we have within our products. That is a DC single-phase hybrid unit which works with low voltage batteries. Thank you.
Thanks very much.
Okay. What we'll do, Patrick, we'll start the webinar now. I'll go straight into my presentation. The presentation today is going to be focused on the GoodWe energy storage range. We touched on it yesterday. Fouty will be stocking our range within the Irish market, and through them and a strong partnership with them, we hope to be a success for not just the energy storage product range, but a complete portfolio of single and three-phase inverters. Right. Right. So day two, we're going to be focusing on the GoodWe energy storage solutions. I'll be just going over the product range very briefly, and then Colin will take over with more in-depth details on the product range and what they can do and what they can actually achieve. I think what many people have gauged from yesterday's presentation is there are a lot of cost savings benefits over the long run by using GoodWe products, because of the technology that we have within them, and also the redundancies within them that a lot of people don't take into account, which ensure long life of the products, which basically are good for you as a company and also good for your customers. Quite brief history about GoodWe. We've been going 10 years now. We were established in 2010, and we've reached a lot of major milestones. As we're focusing on energy storage today, just to let you know, we released our first hybrid back in 2014, and we were selling it in the UK in 2015. And I'm happy to say that we're actually still selling it extensively in places like the UK and South Africa currently. So we were one of the first companies to bring in an energy storage inverter, hybrid inverter, into the market. Some major key moments: we were actually chosen by IKEA to sell. They were selling our products for an EPC called Solar Sentry in the UK in IKEA stores on our residential inverters and battery storage inverters as well. Our second R&D was set up. SEMS is important. I'll go back to this later on in the slides. It's our smart energy management system. And some of the awards that we've won, but we're now available in most markets across the globe. We're moving into Canada and the USA, and we're already established with offices and employees in these markets, as well as our home market of China. Some of the awards that we've won: All Quality Matters Award. It's now for 5 consecutive years, so that's a little bit out of date. But even the EUPD research, we've won for 4 consecutive years as well. This was a major announcement for GoodWe, and it actually shook up a lot of people in the inverter manufacturing world. GE, as you know, are a global corporation. They do have a segment which concentrates on the solar market, but it's more on utility scale with central inverters. But through the deal that we've done with them, which has taken just about 18 months to do, in certain markets, we will be selling GoodWe inverters under the GE brand. It shows that, you know, they've gone with a quality company and they're happy to put their label on our products. Today's, as we spoke earlier, we are focusing on energy storage. This award we've just received recently. We were the world's #1 energy storage inverter supplier, not just for residential single phase hybrids, but also for 3-phase and AC coupled storage units on single phase and 3-phase. It's quite prestigious to get that from Wood Mackenzie. Right, let's just go through the range again. Right, ES, EM, ESA, EH, EHR, ET. I'll go through these a little bit slower today. Anything with an E in there is a DC hybrid. Now we have them in single phase and 3-phase. So it's a DC hybrid that we actually have quite a few of. Right, the differences are the ES, which we originally brought out in 2014, we're still selling today. We actually sell the EM in the UK and Ireland, which is a smaller, more compact version of this. It comes in 3, 3.6 and 5 kilowatt and works with the low voltage batteries. Colin will touch on the battery side of it a bit more in his slide. The ESA is a all-in-one solution that we haven't brought into the UK yet, but we're waiting to see what sort of demand that we have. But this is a product that we can get hold of, and we actually have our own battery that goes in there. Right, the EH and the EHR, Colin will touch on the EHR part of it later on in his slides, but the EH is basically a DC hybrid, comes from 3 to 6 kilowatt, but it works with the high voltage batteries. Now we'll go into the low voltage and high voltage difference a little bit later on in these slides. The ET, again a DC hybrid, but this is 3-phase, comes in 5, 8 and 10 kilowatt. It's compatible with the high voltage batteries. Right, anything with a B in it, SBP, BH, BT, is an AC coupled retrofit storage solution. So we have for single phase and 3-phase. They come in the single phase from 3.6 and 5 kilowatt, which is the SBP, which we sell here in the UK and Ireland, works with a low voltage battery. But we now have the BH, which again is an AC coupled single phase storage solution from 1 to 6 kilowatt, is compatible with a high voltage battery. Now I spoke earlier that these were all single phase units, and we have the 3-phase DC hybrid here, but we also now have the BT, which is a 3-phase AC coupled storage solution. So if you have a commercial building now with PV system already on there and they are not getting the full benefit of their PV system, for instance, it's not being used on the weekend, for instance, and you're exporting a lot, you can actually install, retrofit one of these to an existing PV system and basically generate power in your batteries. So when you come back in Monday morning, you've got power stored there, which you normally would have exported on the weekend. Right, throughout the range, this is basically showcasing the ES, but the EM and the ET, all our products are pretty uniform across the range. You have uninterrupted power, well, basically automatic switchover. There's no manual switch. So if the grid fails within 10 milliseconds, automatically it will switch to backup. So you can have backup power that will power your essential circuits like lighting, refrigerator, Wi-Fi, etc. You can charge your battery from the grid. In our market over here, we don't recommend it on the DC side, but you can actually charge these off the grid. And simple, I highlighted it yesterday. In South Africa, for instance, they know when the grid is going to fail in Johannesburg on a particular day and time. So they make sure that they've got enough power in their batteries before the grid fails. So if you have a bad PV day and you can't charge your batteries enough, you can actually charge them from the grid. Across the range, all our energy storage equipment products come with these ancillary items, which is a smart meter and CTs. The smart meter is actually a separate ancillary device installed when you do the commissioning. It basically picks up the excess energy flow within the property and directs it to the battery for charging and discharging. Energy storage is all about using everything you generate and saving as much as you can and using it for when you need it. These are small, lightweight, compact, but they also don't have there's no fan. There's a big heat sink on the back of the products, which we actually manufacture, and it actually disperses the heat evenly, so there's no concentrated heat build up. Connection to our free SEMS monitoring portal. You have Wi-Fi, LAN, Bluetooth, with 4G coming up soon. This is important. Monitoring we do recommend for all of our products, not just for the grid-tied inverters, but also for the energy storage products. You can actually see, like through the portal on the energy storage products, you know, for what you're actually generating from your regular PV curve. You can see what you're charging, you're discharging. You can actually see the state of charge of the battery. You can see what you're drawing from the grid. There's a lot of information. You can actually see what you're exporting as well. So you can, by looking at your monitoring solution, you can actually configure your system so it works better for your customers. The ET series, this we've launched earlier on this year in the UK, and there is a company that's installing these on rural railway stations up in the north of England, the 10 kilowatt versions. Basically, it's a 3-phase DC hybrid, works with a high voltage battery. Again, automatic switchover. You can charge the battery from the grid. Smart metering CTs included. You can basically limit your export to 0, so you're not sending anything out to the grid. Helps, well, basically 100% overloading within 60 seconds, and it also helps with unbalanced power supply, 3.3 kilowatts per phase. Colin will probably touch on this later, but this is one scenario that you can actually use for the ET. They can actually be paralleled. So in this example, if you have 100 kilowatts on the roof, you can have 10 of these 10 kilowatt ET units, all with their own individual bank of batteries. So totaling that, in this example, up to 100 kilowatts. So there's a lot of battery storage there. They're controlled by this separate device called a SEC 1000 hybrid. Basically, what this does is it controls all of these units connected in parallel, so they work in unison, so they all charge and discharge at the same time. For each bank of batteries, depending on what battery manufacturer you use, you can have up to 9 kilowatt hours per ET, up to 22 kilowatt hours worth of storage capacity. So, you know, that's a lot of storage capacity you have there if you want to use this parallel solution on a commercial building. Coming soon are our commercial storage product offering. These will range from 50, 100, 150 to 200 kilowatts. As I said, anything with an EM there is a DC hybrid. And Colin will explain the difference between DC and AC coupled storage solutions soon. But anything with a B in there is an AC coupled retrofit storage solution. They're completely modular in design. These cabinets are about 2 meters high. You have help with adjustable reactive power, built-in remote shutdown, again automatic switchover, and it helps with unbalanced power supply. Right, we spoke about our products, and what we're finding is a lot of battery manufacturers are bringing in now high voltage battery solutions. We've seen these in the marketplace before over the last 4 to 5 years. The B-Box, the Pylon Tech, the Alpha, and the LG. Now we're all compatible, all our low voltage products on the hybrid and on the AC coupled side are compatible with these low voltage batteries. But what we're finding now, battery manufacturers more and more are bringing in a high voltage battery solution like BYD, LG Chem and Dynes over here with Pylon Tech as well. So our products, we've had to manufacture products to be compatible with these high voltage batteries. Now, this slide is quite old. Fauci are actually stocking a battery called Soluna now, which is compatible with our three-phase ET series, and he keeps these high voltage batteries actually in stock. And we assume sometime in the future that Soluna will have a low voltage offering that will be compatible with our low voltage batteries as well. Right, monitoring. 12 languages across the globe. Our monitoring portal is available in, soon to be 13. This is just one page that you can see on our SEMS monitoring platform. You can scroll along this PV curve here, and once you stop, you can normally see some data. You can have your generation statistics, daily, monthly, annual, over here on the left. What type of system it is, up here in the top left. What sort of capacity is, when it was commissioned, and where the system is. Just over here, generation and operational statistics, accumulated generation. You can find from these fields here. And again, basically more inverter status information can be gauged here. If you hit a button around here, you can actually go into this screen here, which is your main dashboard. A lot of EPCs and large installers, even small installers like this, because they can actually monitor multiple installations that they're actually directly involved with. And you can actually configure this whole screen to how you want it, so you can actually tailor it to how you need it. Bottom left here, you've got environmental statistics, more generation and calculation statistics, but all in all, our SEMS platform is evolving all of the time, and you know, we will be incorporating EV charging and things like this for little mini grids in the very near future. Some case references. I did these briefly yesterday. There's 11 megawatt in Holland. We'll just skip through these because these are basically large projects, and we're looking at battery storage. There's a couple here in the UK. 2.3 megawatt in the UK, 200 kilowatt, 354 kilowatt. There's one there in South Africa. Another solution here, in smaller residential solution here in South Africa. This is some EMs configured here in the UK. I think that's ET in South Africa. Sorry, in Czech Republic. This is our all-in-one storage solution. I'm not sure where that is. Energy storage is coming into play. Thank you for your time. I'm just going to
Okay, thank you, Raj.
Okay.
So good afternoon, everybody. Thank you for joining us again today. For those of you who are new to joining us today, I'm Colin Poulter. My responsibilities in the UK and Ireland are for pre-sales and service activities. So I'm just going to pick up on the battery storage solutions today. Our residential battery storage solutions, I should say, and then going to finally just finish with a brief introduction of our commercial solutions that we will be offering very soon or later this year. So here we are, Goodby Residential Energy Storage Solutions. So the first thing I'd like to just go over for those of you who aren't familiar is some terminology that you've heard Raj talking about just now. So you've heard the terms DC coupled, AC coupled, and DC coupled we usually associate with being a hybrid inverter. AC coupled we refer to when we're using a charge controller, or we think of it in terms of being a retrofit solution. So if we have a look at the DC coupled version first, which is at the top of the screen here, you can see that between this hybrid inverter in green and the solar panels, there is a direct relationship, a direct DC relationship between the solar panels and this product, which is the hybrid inverter. You can see here at the bottom, the AC coupled solution, that there is no direct relationship between the input of this charge controller and the solar panel's DC output. There's no direct relationship. Now, the way that energy gets into the battery slightly differs between the DC coupled and the AC coupled. So if we just stay down here on the AC coupled solution, the only way that the battery can pick up charge energy is from what is present on the AC bus. So if you can imagine a property has an inverter installed and that excess energy would be going back to the grid. If you add in what I call a charge controller, it's going to be able to detect through the use of our device, a smart meter, what excess energy could be going back to the grid, but instead it's going to redirect it into the battery. Similarly, for the DC coupled solution, the energy, excess energy, when that's detected as going back out to the grid, there'll be signaling back to the hybrid inverter, but solar panel power can now be directed over DC into the battery, so to charge the batteries. So that's just a brief distinguishment between the DC coupled and the AC coupled. You can probably see I've got fit meters in here. Well, that's obviously not relevant to Ireland. That is more relevant to us over here in the UK. And it's important to know the difference between an AC coupled solution and DC, because you can impact upon a feed-in tariff. But as I say, that's not relevant to Ireland. So we will move on now to the next slide. So continuing with terminology, we've spoken about low voltage and high voltage batteries. Well, nominally, the low voltage battery is around 48 volts. And with our equipment that uses low voltage batteries, you can increase the capacity of a storage system by putting these batteries in parallel. So you'll always be presenting 48 volts to the inverter, but to increase the capacity of storage, you put the batteries in parallel. Conversely, the high voltage batteries, these batteries are put in series, and as an example here, I've got the voltage range of the ET shown here. So the voltage range for this is 180 volts to 600 volts. So you can see here that by virtue of these batteries being in series, you'll increase the voltage range. Now we do have a battery compatibility list which shows all the batteries we are compatible with. That's published on our website. And just to re-emphasize, I guess, the term retrofit we usually associate with the AC coupled device, or calling it a charge controller. The hybrid is essentially a charge controller and inverter all in one box. Okay, so let's move on. Here, what you'll find is that all of our hybrid solutions all have common features running through them. And that is the fact that they're all app controlled. So for configuration of the inverter, we have an app to configure the system. That's called PV Master. We also have an app called SEMS, the SEMS app, which is an end user app mainly, so that they can monitor their system on the go when they're out and about. They can view the system on their phone. BMS here, all of our systems require them to be lithium battery compatible, so they all have built-in intelligence within them with a BMS, so that the batteries will be intelligently controlled between the inverters or the AC coupled units to the batteries. On the right hand side here, up at the top right, they all have the ability to operate in an on-grid mode, and when it's not in on grid, the grid's been lost, then it can switch over to a backup. So we have two AC ports on our equipment. As I say, one is on grid, and then when the grid's lost, power is switched over to a dedicated AC backup port. And that occurs within 10 milliseconds when there's a loss of grid. So we can generally refer to it as being a UPS supply. So at the bottom right here, we refer to it having anti-reverse capability or export limitation. Now, the smart meter has that capability, and that's what's used to control the energy flow and the charging and the discharging of the batteries. What I do have here is that very smart meter. So you can see it's quite small. It's there we are. This is a three-phase version. So from this, you'd have 3 CTs, and then there would be a comms cable connection there as well that would send the information back to the inverter. Anyway, let's move on. So, okay, so I'd just like to run through the operational logic of our equipment, and hopefully what you can see here is an example of a hybrid inverter. And as you can see, the solar panels here are input into the hybrid inverter. Then at the bottom you have the battery connection, the power connection, and the BMS connection, which is shown in dotted yellow here. Just under, or just to the right of the battery connections, we have the on-grid AC port. Now this is generally the supply into the main consumer unit or the building where all the main loads are. But in red here, we are just showing the backup port connection. And this is where you'd connect some essential loads to, so refrigerators, that kind of thing. If you're fitting this into a property that's already got the main consumer unit configured, and it's very difficult to change the wiring configuration, then you could consider adding in a small, something like a garage unit or something like that to supply power to, from which you could then have a socket which you could use as a means of plugging in some specialist piece of equipment just to be used on that backup port. That's just an idea, and that's quite a favourite idea of how to use this. At the top here, this dotted yellow line going towards the smart meter, that's an RS485 communication connection. And then from the other side of this smart meter, we have the CTs, and the CTs are clamped onto the main incomer within the property to detect the energy flow. So that's a typical setup here. So let's imagine now that the sum of loads here comes to, let's say, 500 watts. It's a small load. And let's say we've got 3 kilowatts of energy being generated by the PV. So what happens here is that the energy is 500 watts worth of energy is consumed from the output of the inverter, which leaves 2.5 kilowatts that would otherwise go out to the grid. But because we've got this CT here and it's monitoring that incoming point, it's going to detect that there's an attempt to push that power out onto the grid, and it's going to very quickly signal back to the hybrid inverter to say, no, don't send it out to the grid, use that power to charge the battery. And it's going to start charging this battery. Now, depending on the type of product that you have here, depends on how the charge rate of the equipment and the speed at which the batteries charge, and of course also that depends upon the capacity of the battery as well. So that's the process that occurs. Now, if that battery becomes full and you can't charge that battery anymore, and we're still generating energy from PV during the day, then of course the only thing that can happen is that excess energy will go out to the grid. Okay, so let's now look at the other side of the coin here, where perhaps it's a very poor PV day and we're only generating, again, let's say 500 watts. And let's say that the building demand is, just as an example, let's say it requires 3 kilowatts of energy. So we're not producing very much power here, but because we know we need some extra power demand, this inverter will detect that, and if there is the capacity within the battery to be able to discharge to help support the loads, then it's going to do that. So now we've got power coming from the PV and we've got power coming from the battery. And again, depending upon this particular device and its power output capability from the battery side, if that's still not enough to meet the demand of these loads, let's say the loads were 6 kilowatts, then of course the only thing that can happen is that you're going to have to draw energy from the grid in order to be able to support these loads. Now, when this battery is discharging to support these loads, there is no, when it's on grid, there is no priority over the loads being supported on the backup side or on the on-grid side. Okay. What we need to look at here is what happens when we lose the grid connection. So as you can see here on the right-hand side, all the AC connected devices now are disconnected because we've lost the grid. So that only leaves now the power ability from the inverter via the PV that's generated and the battery. So this is only sent to the devices which are connected on the AC backup port. Now, when we lose the grid, you can quite seamlessly see that these devices here, whatever's on this load here, will be supported, and it's within 10 milliseconds. As I say, it's more or less a UPS supply. Now, this can only support the output power rating of the AC backup port. If you go over that, you'll overload the inverter and it will actually switch down, so it can't damage the inverter. Okay. So that's, or this screen, I should say, this is looking at the AC retrofit solution. So this is the kind of solution that if a customer already has an inverter, but they're now interested in having some battery storage capability, then they can add in our charge controller here on the left-hand side, which is shown here. And on the right-hand side, this is representing the inverter that they have within the property that is already there. Now, this inverter can be any brand of inverter. And when we add in our charge controller, because we're only going to be monitoring the AC power that's potentially being exported back to the grid from the inverter, then the charge controller is agnostic to whatever inverter it's monitoring the power from. So a slight difference here from when I showed you the charge controller earlier is that the RS485 communication to the smart meter here shows that on the output side we have a CT exactly the same as before, which is performing the monitoring of the incoming and outgoing power to the grid. But we now have this second CT, which is there purely to monitor the power that is generated by this inverter that's existing. So what that enables to happen is that on our SEMS portal, you can now monitor and show the amount of power which is being generated by the inverter. If you didn't have this second CT, all you'd be able to see is what the charge controller is doing, and you're not going to be able to see what this inverter is generating. So it's just to be able to help you look at the portal and see how the performance of the charge controller is working compared to what the energy is being generated from the inverter. Okay, so that's the AC retrofit solution. So here, now you've just seen that a few moments ago. I'm just going to touch on this again. This is our hybrid solution. Sorry, this is our three-phase hybrid solution, the ET. The maximum size of the ET is a 10 kilowatt size. It comes in 3 sizes, but we'll just look at the 10 kilowatt here, for instance. Now I've got 3 ETs here that are paralleled, and when I say paralleled, it's only on the on-grid AC side that the inverter is paralleled, just the AC side. Each inverter's backup side is only responsible for the essential loads that it is connected to. So as Raj said, the SEC 1000 hybrid piece of equipment here, this is responsible for, when it's on grid, it's going to control intelligently the discharge and charge capability of the batteries across the whole set of ET inverters when it's on grid. When it goes off grid, you lose the grid supply. Then each inverter is going to supply power to its local backup supplied loads. And on the left here, as we said, it's a maximum of 100 kilowatts because we can have 10 of these in parallel, but we also are able to support unbalanced loads. Now I'm going to show you something about that a little bit later. And as we said, smart control, that's achieved via the hybrid SEC 1000. Okay, so let's move on. Let's have another look, another way of, or another solution, how you can increase the energy capacity within a property. So let's say it's already got an on-grid inverter there, and this particular property could benefit from both extra PV and battery storage. Well, you can actually add in a hybrid inverter. Now, what the hybrid inverter will be able to do in this particular instance, it will be able to, again, because of the CT clamp at the incomer to the property, it's going to be able to detect the excess energy that is generated from both this on-grid inverter and from the hybrid inverter itself. So it's going to be able to use the combined amount of energy to charge the battery. So that means you could perhaps now benefit from increasing the size of the storage or the storage capacity. So that's how you can increase or extend the solution. Okay, the next slide here. Now this concerns our equipment called the EHR inverter, and essentially well, it comes in three flavors basically. You can purchase this in 3 different ways, and at the bottom here you can see that I have listed them as A, B, and C. So if you went for option A, this is essentially a complete hybrid inverter. This is already purchased with all the features available to it. Option B here is if you purchased the EHR, but you weren't quite ready for any battery storage solutions at this time, but you're interested in having it as an inverter, then you would go for this option. But you would also be bearing in mind that you would perhaps in the future be buying batteries, and therefore you probably want to purchase this smart meter as well, because that smart meter is going to give you the indication of the performance of load usage of the building, and it's going to be able to let you determine what kind of battery, how many batteries or what storage capability you're going to need. Then there is the third option here, option C, where perhaps you're not even thinking about batteries at this particular moment in time, but you're bearing it in mind. So you just simply buy that as a regular inverter with the option perhaps later on that you would actually like to purchase battery storage solutions. So that's just the 3 versions here. And you just representing here this activation code, which will enable the battery storage side of this piece of equipment. Okay, so that was that one. Now let's have a look at the ESA, which is our all-in-one pre-packaged solution. And as you can see here at the top, we have a 5 kilowatt hybrid inverter. Essentially, that's our ES inverter. Now, in the part of the cabinet just below that, there's a pre-wired box which integrates all of the wiring and connection points. And that's shown here on the left-hand side of the screen. And you can see within that box, we've got the Wi-Fi connection there. It takes the input, the DC input from the solar panels, and the isolators for the solar panels incorporated in there. It's also got the on-grid breakers that are within this unit, and it's also got the off-grid breakers there as well, or a backup port. Now, in the middle, just between the two sets of AC breakers, there is a bypass switch. Now, if maintenance needs to occur to this unit, then you're going to have to power this unit down. But when you power the unit down, all the AC backup supply is lost. So because you're going to have fridges and essentials piece of equipment connected to this port, obviously you don't want to lose that power. So you just flick over this bypass switch and it's going to supply energy to that from the grid. So you're not going to lose a supply. So at the bottom here, just to complete this then, we have the battery bank, which we will be supplying our own batteries for, and that's in the lower half here. Okay, let's go on. Okay, so we've had a look at the different types of equipment and some of the setups and some of the operational features of it. So what I'd like to show you here is how you can use our app called PV Master to control the energy usage from the battery. Now, within PV Master, there's various pages. On the advanced page, as I'm showing here on the left-hand side. I don't know how clear that is for you, but on the left-hand side of the screen here, you can set up the depth of discharge that you would like to allow the batteries to discharge to when the equipment is on grid, it's generating, but you've still got an on-grid connection. But you may be aware of the area that you're in, you potentially can lose the grid for a short period of time. So you may want to reserve some battery power for those situations. So this feature, by combination of setting the depth of discharge on the on-grid side and the depth of discharge on the off-grid side, by setting those two, this will enable you to control the amount of power that's reserved for an off-grid situation. Now, on the right-hand side here, one of the very first things you're going to meet in when you're configuring these systems is the whole operational mode of this inverter, and there are essentially 4 options here. The default option is general mode, but what I'm particularly drawing your attention to here is the backup mode. Now, if you're in an area, or the customer's in an area where they perhaps regularly lose the grid connection, as an example, South Africa, this happens quite frequently. So they would only ever want to be using the battery in an off-grid situation. So during the daytime, when we're generating power and there's a demand from the building for a load, then we would not use any of the battery power at all. This would all be reserved for an off-grid situation. So that's the option you could choose with this backup mode. So that's another way to configure the system if so desired. Having another look at the ways that you can control the battery, charge the battery or discharge the battery. Again, if we have a look at the work mode options, which is within the PV Master app, then there is an option in here called economical mode, which is shown here at the bottom right. Now, what this enables you to do is to set up times of day that you want the batteries to either charge or discharge. And just shown here at the top, just where my mouse pointer is, you can set a start time of when you want the battery to charge. You can set the end time when it should finish charging. You can set the rate at which power is discharged or charging. So 100% would represent the charge or discharge capability, the maximum output power of the inverter. And beneath there, the battery mode, you'd set it to, if you wanted to discharge, you set it discharge. If you want to charge, you set it to charge. So having configured that, then you could also set up a repeat timer. So you could set that to occur every night if you wanted, at particular hours of the night. So the benefit of that, of course, is people have different or various different types of tariff that are available. So if you're on the type of electricity tariff where you could pay for cheap rate energy at night as compared to what it would be in the daytime, then you'd be able to charge the batteries quite cheaply at night, and then you could use the stored energy within the battery and discharge that energy during the course of the day. So it's a good way of saving cost and using the system. Okay, let me go on to the next slide here. This is just a small snapshot of some sections of the SEMS portal. Now, I don't think this would be very clear for you to see, but what we're showing here is the daily and the historical information that is reported to the portal about the inverter, and this happens to be showing the report of a hybrid inverter throughout the course of 24 hours a day. So in actual fact, this is only 12 hours shown at this point, I think, but it will show 24 hours worth of data. This is just showing you one particular graph. This is showing you the load consumption of this particular property. The other graphs that are disabled on this view at the moment. You'll be able to see the full PV that's being generated. You'll be able to see when the batteries are charging, when they're discharging. You'll be able to see what's going on at the incoming point to the building. As I say, you'll be able to see what the load is. And you also, and most importantly, you'd want to be able to monitor the SOC, or the state of charge of the battery. And that's all contained there within that view. Beneath there is quite a useful view. It's what we call our real-time monitoring view. It's as real-time as it can get in terms of course, the data has got to be transmitted from the inverter up onto the portal and displayed graphically here. There is some latency there, of course, because of that delay in transmitting the data. But it's a good representation, it's a good visual indication of actually what's going on, so that you can see the solar power is being generated, it's being used by the building. You can see that at this moment in time, the batteries are fully charged, therefore there is excess power that's now going out to the grid. So this is a good visual indication. Of course, the arrows change direction depending upon what's happening with the battery when it's charging or discharging. At the top right here of the screen, we have a daily, monthly, yearly calculation showing you the self-use ratio of the energy that's being generated, how much being consumed by the building, what's being consumed from the battery, etc. And also to support that, just underneath, there's some pie charts here which give you a visual indication of the self-use analysis of the PV and also the consumption of the building here. So that's the visual, or part of the visual information that's presented to you on the SEMS portal. Right, here is what you would receive in a box if you were to buy the ET inverter. And you can see here the image of what that inverter looks like. And of course, you've just seen that. No, you haven't seen that shown in Fulty's display at the moment. But what I am showing here is the fact that we do have two pre-wired cables, communication cables. One is used for the connection to the smart meter, which is shown here at the bottom left. And the other pre-wired cable is the communication cable to the battery. This battery communication comms is generally going to be the CAN protocol that's used. So if we just have a look at what else is within the box, the Wi-Fi module, Bluetooth is coming out very soon. So rather than making a Wi-Fi connection from your smartphone for configuration, you'll be able to use Bluetooth. And also here we have some communication splitters as well. So if you're going to be paralleling the ET, you need to be able to transmit the comms from one device to another, and we supply this within the box. This is what we call our communication splitter. Now, just coming back to the smart meter, where this is usually located is down at the incomer of the property. So generally you'd want to contain that within some form of box, because it has to take a main supply. So you need some sort of protection there. But generally everything else is contained within the box. Right, so we've spoken about the UPS level switch time. So this is just a little explanation of how it works. And when it's on grid, you can see here that the inverter via relay 1 and via relay 2 is connected to the grid, and this is how power is supplied to the inverter. But when there is a break in power from the grid within 10 milliseconds, relay 1 and relay 2 will open. So now we have disconnected from the grid to maintain regulations, but you can now see that relay 3 has closed, so that the inverter is capable of supplying power to the backup output port. Okay, so we're nearly approaching the hour, so I better continue here. This is just a laboratory environment situation in which, in our headquarters, they've gone through the process of installing one of these. And it's just an idea to give you an idea of the relative times of setting up each part of the equipment. Of course, in reality, you know, every single scenario is going to be different in each property. But this is just, as I say, it's just to give you the relative proportion of time in setting up each part of the system. Now, what we need you to do is be able to connect all of these devices onto the portal, and what that means is that the Wi-Fi signal that is broadcast from the inverter will need to be paired up with a local router within the property. And once that pairing is performed, that means you can then get excuse me, you can then get this information about the inverter up onto our portal. And there's various different ways of doing that. And just briefly, there's one method within the app that enables you to do that. Again, looking at the PV Master app, what you need to do, you set up the physical side of things, and now you need to commission this. So it's a 4-stage process in order to be able to get this piece of equipment operationally correct. And what you need to do is, from your phone, which has got the app PV Master on it, you connect over either Wi-Fi or Bluetooth, a direct connection to the signal that is being broadcast by this inverter, and then you'd run through to the point within the app to the screen called Basic Setting. And within Basic Setting, the first thing you'd have to do is set up the safety country code. So of course you configure Ireland, and then you press Next to take you onto the next screen, which would enable you to set up the operational mode, which we've already addressed in previous slides. Having done that, we can now select Next, which takes you onto the screen where you'd select the batteries that you selected to be used with this system. So you just go through the drop-down menus and select the appropriate configuration, and then the final step would be to press Next to get you onto this final screen called Meter Test. Now, Meter Test enables you to ensure that you have got the CTs connected on the incomer the right way round, because there is an orientation required with the CTs, and this enables you, providing that you have got the equipment all configured and all set up correctly, this does enable you to check that the CT is correct. Then, having got the result of the meter test and it's passed, there is a final screen which it suggests you need to restart the equipment, but it doesn't actually mean that. All it means is press yes to apply the configuration, and then automatically all of those settings that you've just selected on the previous 4 steps will be applied to the inverter, and it will be ready to use. Okay. Right, so I said I'd talk about unbalanced output when I introduced you to our ET series. So we're coming back to the ET series here. So this is important because as this picture will show you, for both the ET and the BT solutions, let's take this example here. We've got a 1 kilowatt load on phase 1, we've got a 3 kilowatt load on phase 2, and we've got a 2 kilowatt load on phase 3. So they're all different load levels. Now, in the situation where we're going to inhibit any power from being, any excess power from being sent back to the grid, in other words, we're going to be using our export limitation capability. If we didn't have the unbalanced output capability, what that would mean is, even though perhaps this inverter was generating at its maximum capability of, say, 10 kilowatts, that would mean generally 3.3 kilowatts on each phase. What that would mean is, because we are only able to supply, because we're now not going to be able to export any power back to the grid, what that means is this inverter is going to derate itself to the lowest demand level on the lowest phase supply. So in this instance, on phase 1, the 1 kilowatt load is what this inverter is going to have to derate itself on each phase. So rather than 3.3 kilowatts in each phase, it's going to derate each phase to 1 kilowatt in order to be able to supply what's needed by the lowest demand on a phase. So what you can see here is that now, as we've only got 1 kilowatt being produced to each of the phases, for phase 2 and phase 3, we now have a deficit in energy being produced from the inverters. So that means you're now going to have to draw energy from the grid to support these loads. So obviously that isn't very good. So that's why we have the feature of unbalanced output. Now, when you set that mode, what that means is you can now actually control exactly the demand from each phase individually to supply to the demand on each phase of the load side, with still maintaining no export. So that's why we've got this capability here. Now, in the diagram below, just looking at the other side of things, when we're charging, we've got 4 kilowatts being generated. We don't want to export any power. We've got different load demands within this property, and 1 kilowatt on phase 1, let's say 2.5 on phase 2, and 2.5 kilowatts on phase 3. So now, because we've got this unbalanced charge capability, we can take the excess energy, the individual excess energy from each phase, and we can use the combined output to charge the battery. So again, this is a useful feature to take all of that energy. If we didn't have the unbalanced charge capability, we get a reduced charge amount to the battery. So up here, we're saying we've got 100% unbalanced output capability. So that means if there was no demand on phase 1, but there was a 3.3 kilowatt demand on phase 3, we can support that. So that's why we're saying we've got 100% output balance capability. It's available on both the backup and the on-grid side. By default, it's available on the backup side. As I say, it's configurable through the app. And of course, we don't need any extra devices to have this facility. It's all incorporated within our equipment. Okay, so Raj has already gone through the batteries. So just a quick reminder, this is the low voltage pieces of battery that we have, and the high voltage at the bottom here are the solutions that we also offer. So this here, what I'm showing you here is the fact that we have the ability, because of the types of protocol that we have within our equipment, and the different types of protocol we have are Modbus RTU, and we'll be having Modbus TCP as well, and SunSpec protocol. This just show you that we are very integratable within systems such as a virtual power plant. So you can see here that we've got a piece of equipment, and you can see that there's going to be intelligent control between the various different devices within this virtual power plant to exchange power and control things very effectively. I think this is my final slide now. Oh, final slide is just, again, just to recap the fact that we do have an AC coupled and a hybrid solution in our commercial offerings coming up, and they will range between 50 and 200 kilowatts. They do have this capability, which I spoke about yesterday, which is the ability of providing some power factor corrections. So we have adjustable reactive power within these solutions between minus 0.8 and plus 0.8. They will have built-in remote shutdown, so the grid will be able to shut these down if necessary, grid operators, I should say. And as you can see, it's a very modular design, so it's a rack-mounted solution, all neatly contained. UPS level switch time, so again, when the grid's lost, we can switch over to the backup supply very quickly. And as I've just been explaining about unbalanced output loads for the ET, we will similarly have that for our commercial offerings as well. So thank you very much for your attention today. I hope you have got some benefit from this information. I'm just going to drop you onto this last slide here. Just go back to that. We are running what we call our GoodWe Thumbs Up contest. It's just if you go onto a media platform, LinkedIn, Facebook, whatever you have, just if you give us a thumbs up, you do get an opportunity to win an Amazon voucher. So that's just a little nicety for you there. Anyway, I'm going to hand you back over to Raj now, because I know we're pushing over the time limit. So thank you once again. I'm going to stop sharing my screen and hand you over, Raj.
Thanks, Colin. Once again, just to reiterate what Colin just said, thank you for attending today's webinar. We hope you got some benefit from it. By all means, if you have any questions, send them to our partners at Fauci Solar, and they'll be more than happy to help. And again, just to go over, they carry a very good stock of GoodWe products. anything that you think you may need in the future, please contact them directly, and I'm sure they'll be able to get the products in as and when you need it. And I think for this month, they are running a 5% offer to launch properly within Ireland. I'll just hand you over to Patrick from Faulty. Thank you, everyone.
Thank you very much, Raj. And thank you so much, Colin, also. Very informative, very well presented presentation today. We're delighted. Fáilte Solar is delighted to be a partner with Goodway. Just remember, our phone number is 061 475 5839. Call us. Any questions you have, we'll try and answer. And of course, we will be constantly in touch with Goodway to introduce all the solar products in Ireland. Again, thank you. We're here to help, we're here to service, and we appreciate all the support from you. Thank you, Raj. Thank you, Colin. Good afternoon.
Have a good day, guys. Thank you. Cheers. Bye.
Bye.
Bye-bye.